why are we doing these? What's the point of doing conversions? Frequently, the unit you measure in is not the unit you calculate in. So frequently you need a different unit than what you measured. Okay, frequently you need a different unit than what you measured. For example, you need to calculate things in meters. However, if you're trying to measure the distance from your house to school, you would most likely use kilometers. Okay? Well, kilometers you can't use in the calculation, so you'd have to convert between them. Okay? All right, so that's why we do it. So what's a base unit? It's the standard unit of a measurement. And for right now, the three measurements we're going to talk about are distance or length, whatever you want to call it, mass, and time. So, the base units for these are: distance is meters, mass is grams, and time is seconds. Meters is M, grams is G, seconds is S. Okay, so when I talk about prefix units, what am I talking about with prefix units? So prefix units are scaled up or scaled down versions of the base. So they're scaled up, which means they're bigger measurements, or scaled down, which means they're smaller measurements of the base. So for example, meters is the standard unit, that's the base unit. If I want to measure something that's larger than meters, I would use kilometers. If I want to measure something smaller than meters, maybe I use centimeters. So it scales my number up or it scales my number down. So, what are those actual prefixes? Now, you've probably seen a bunch of them before. I'm just going to do the ones that matter to us. Okay, so those units are kilo, then the base, and I'm going to do the base in a different color just because the base is kind of like the middle point. Yeah, it's not the middle, but it's kind of like the standard spot. Then we have centi, milli, micro, and nano. Chances are, if you've done conversion before, you're wondering where deci, deci, and hecto are. Where they are is nobody cares. Nobody cares about those three. No one ever measures things in hectometers. Nobody does. Okay? So, to me, they're pointless to convert to because nobody uses them. Okay? You also may not be familiar with micro and nano. Micro are used to measure really small things like bacteria. Nano are used to measure even smaller things like the width of your hairs. So nano and micro are really small things. Now, all of these have a symbol. The symbol for kilo is K. Symbol for the base is whatever it is, so seconds, meters, grams, whatever. Centi is C. Milli is M. Micro, get ready for it, is the Greek letter mu. It's a funky looking U. Micro is a weird looking U. If you don't remember it, like if you look at a problem, you're like, what the heck is that thing? It's micro. If you don't know what it is, it's micro. And when we get into the practice today, I included that. Okay? I included that symbol so you don't forget. Okay? And the last one, nano, is N. So what we're doing is we're trying to find a conversion factor. For example, you know that 1 hour is 60 minutes. So you can go between hours and minutes by multiplying or dividing 60. But it's because we know 1 hour and 60 minutes are the same thing. What we need to do is we need to figure out 1 kilo and something else that are the same thing. Okay? So we're going to do one of all these prefixes. And we're going to relate them to something else. In this case, kilo is 10 to the third base units. And don't worry, I'm going to come back to what these are. I'm going to explain them more. Base is 10 to the 0 base units. Centi is 10 to the negative 2. Milli is 10 to the negative 3. Micro is 10 to the negative 6. And nano is 10 to the negative 9. Okay. First of all, I have good news for you. You do not need to memorize these. I'm going to give them to you. You do not have to memorize them. They're going to be on the test, they're on the practice, they're on the review, they're on everything. Can I take a picture? Yes, real quick if you would. Okay. All right, second thing. What the heck did I just do? All right, so let me try to explain what these numbers are. What's up with this 10 business and that sort of thing? So this is called the metric scale. The metric scale scales by 10, powers of 10. So when I have 10 to the third base, what that means is that there are 3 factors of 10 for every base unit in a kilo. What that means is it's 10 times 10, which is 100, times 10, which is 1,000. So what I mean is there are 1,000 of the base unit for every 1 kilo. So there are 1,000 meters in a kilometer. There are 1,000 grams in a kilogram. Okay? Base. Base is 10 to the 0. Well, 0 tens. What are you left with 0 tens? You're left with just 1. So the base is just 1. Centi is 10 smaller. 2 sets of 10 smaller. 1 set of 10 smaller is a tenth. 2 sets of 10 smaller is a hundredth. So centi would be 0.01. I'm not going to go through the rest of these because you don't need to be able to do this. I just want you to see where these magical numbers came from. Okay? They're not just things I made up. They're really there because of how much the difference is between these things. Okay? Okay, so let's go ahead and let's do an example here of converting. So you can see one, so I can make sense of it for you, and so you can see one to try out on your own. Let's do the following. Let's do 13 seconds into milliseconds. Okay, first thing I want to tell you, you have to show your work or you don't get points. Okay, on the test, you have to show me how you convert it, but you won't, otherwise you won't get any points for it. Secondly, I don't care how you do it, as long as I can tell how you do it. So you can't just move the decimal, because if you just move the decimal, I don't know why you moved it that many spots. But what you can do is move the decimal and tell me, why did you move it 6 spots? Why did you move it 2? And you could just say, I moved it 2 spots because centi is 2 away from the base. Okay? That's totally fine. Some of you have taken chemistry before, and so you're used to like the picket fence thing. Do it. I'm totally fine with that. If you know how to do the picket fence thing, do the picket fence thing. If you don't know how to do either of those, do it the way I'm going to show you. Because the way I'm going to show you is, quite frankly, easier. And it shows the work so that you can do all of the things. So you can show your work and it won't take you way too long. Here's how I do it. I do have minus get. You take what you have minus what you're trying to get. So I have seconds. I'm trying to get to milliseconds. So what I have is a base unit. So what I do is I go up here to my scale and I find the base, and here it is. And how many base units are there in one base unit? 10 to the 0 base units. So my have is 10 to the 0 minus what I'm trying to get. I'm trying to get milliseconds. So I go up here and I find milli. For every 1 milli, there are 10 to the negative third of the base. In this case, 10 to the negative third seconds. So I put 10 to the negative third. Then I subtract. Now, when you subtract, you don't do anything with the 10 except leave it alone. What you do subtract are the powers. 0 minus a negative 3. Now, whenever you have two negatives, remember they cancel. So minus a negative, you add the opposite. Okay? So minus negative 3 is actually plus positive 3. So 0 plus 3 is 10 to the third. Okay, we're not quite done yet. We're almost done. This tells me what to do to my original number. I need to move 3 values of 10 positively, which means make the number bigger. So here's my number, 13. If you don't see a decimal, put one at the end of the number. And move the decimal 3 places right to make it bigger. 1, 2, 3. Add zeros where you have blanks. And here's my number, 13,000 seconds. 13,000 seconds. Okay. Let me show you one more going in the opposite direction. Okay, this time we're going to start with 13 grams. And we're going to go to kilograms. Okay, 13 grams. Grams is my base. I go up here to my base. My base is 10 to the 0. Minus what I'm trying to get. I'm trying to get kilo. Kilo is a value of 10 to the third of the base. 10 to the third. 0 minus 3 is negative 3. So I'm moving the decimal 3 places. Again, if you don't see a decimal, put one at the end. I'm moving it 3 places left to make it smaller. 1, 2, 3. So my number is 0.013. Okay. MKS. So MKS is actually really simple. You have to know what they stand for, though. So MKS. Here's what they stand for. They stand for what the standard normal calculating units are. These are not the base units necessarily. These are the units we use to solve problems. And those units are meters for length, kilograms for mass, and seconds for time. So let's look back at practice. Let's actually look at measurements 2. Let's look at measurements 2. Let's look down here at the bottom of that page. Here's all I mean with MKS. All I mean is you need to figure out what to go to. Remember we do have minus get? All you have to do with MKS is you have to figure out what the get is. On the previous problems, I told you what it was. Get it in kilograms, get it in kilometers, get it in millimeters, get it in nanometers. In this one, I'm not telling you what to get. You have to figure out what to get. So, for example, centimeters is a length. The standard unit for length for calculating is meters. So I send it into meters. Grams. The standard unit for grams is, or for mass, is kilograms when we're solving. This is the only weird one. The rest of them are all bases. Kilograms is the standard unit, though, for mass. So I go to kilograms. Okay? Hours go to seconds. Seconds is the time unit. You don't convert any differently. You don't do anything different in the conversion. You just have to figure out on your own what am I going to. That's it. Okay? So that's MKS. That's all it stands for, meters, kilograms, seconds. That you need to know. You need to know what that stands for. Because on the test, you're going to say a question where I say, put this number in MKS units, and you'll have to figure out what you need to get it to. Okay? All right. Let's jump to the back page of the notes. Let's talk about more complex conversions, and let's talk about time. So, for these more complex conversions, notice that all the ones we've done so far, you've gone from like milli to base, kilo to base, base to kilo, base to micro. They've all dealt with the base. Here's one that isn't. Centimeters to kilometers. Okay. So, you do it just like we've done. Have minus get. I have centi. Centi is 10 negative 2. Minus get. I'm getting kilo. Kilo is 10 to the third. Negative 2 minus 3 is negative 5. I write my number, 6,700. Decimal at the end. 5 to the left. 1, 2, 3, 4, 5. Add a 0 where I have a blank spot. And here's my number. 0.06700. That's it. You do it just like before, but there's no base this time. Just fine. You just do it the same way you did. Okay, let's talk about time. Time is easy, except it's not. Notice that hours are not on here. Neither are minutes or years or days or any of those things. They're not on here. Okay? You have to do them a different way. Start with the number you have, 3.5 hours. I need to get to seconds. But in order to get to seconds, I got to go through some in-betweens. Now, I know there's going to be more seconds than hours, right? There are, if I had to count how many seconds were in a day, I'd have a huge number of seconds for one day. So, I'm going to multiply by things I know fit in an hour. So what's something I know that fits in an hour? 60 minutes. I know that 60 minutes fit in an hour. Okay, I'm done with hours now. Good. Now I'm in minutes. I got to get rid of minutes because I'm trying to get in seconds. Do I know how many seconds fit in a minute? Yes, you guys have all spent time staring at clocks in your life. Okay? 60 seconds for a minute. Now I'm out of minutes and I'm into seconds. All that's left is multiply it together. 3.5 times 60 times 60 equals 12,600. And there you go.